Good morning to all the students. I am Bhawna Aggarwal. Here I am going to give you a small overview of your subject electronic devices and circuits. This subject is being taken by the students of second semester in EC as well as IC branch. So whatever I am going to discuss here, it is related to both the branches, not only EC, rather for IC also. So this subject which we are going to study in second semester, my main objective here is in how much depth you have to study which topic, as various sections are there and in each and every section different teachers are taking the subject. So there can be confusion like which topic to take in how much depth and how to cover a particular topic. So my objective here is to let you know how to study this subject and to prepare good for your exams. So let us start. This is the list of all the books which we will be referring in this subject. The first two books, that is your Cedar Smith and Boylston, these two books will act as your textbooks, and out of these two also your very first book Cedar Smith, I will suggest you that you should have this in hard form if you are going to consider this subject for your future also. For your coming semesters like in electronics 2, this book Cedar Smith is again going to act as your base book. So here only if you have this book in hard form in your hand, so it will be good for you for understanding purpose of the subject. Rest all books we will be referring for some small topics, but main textbooks are your Cedar Smith and Boylston only. Now let us take the topics one by one and try to understand what all things we have to cover in these topics and which book we have to refer to. Your very first topic is your semiconductor physics. To certain extent you have some idea of this topic from your 11-12 standard also. There are various topics that you have already covered in your 11-12 standard, so to certain extent it is common. But here the difference that you will observe is that you might not have studied the graded and step graded semiconductors. Then PN junction diode, you should know the extrinsic and intrinsics as well, and your mass action law. So in this you should know about the mass action law. And numericals related to your mass action law as well as your mobility, resistivity for your intrinsic as well as extrinsic semiconductor. So this you have to cover. Drift and diffusion currents, this also you can cover to certain extent for numerical, but basically till this point it is more related to your theory part. Then later on your PN junction, your step gradient and your mobility resistivity, here small numericals related to calculation of your resistivity, mobility, or using mass action law, small numericals are there. And then Shockley equation, derivation of this equation is not in your course, we don't have to cover the derivation, only you should know what is the Shockley equation and how to use it if any numerical turns up, and you have to calculate the current flowing in the PN junction or your diode. Now similarly calculation of barrier potential, this is important, this you should be knowing how to do the calculation for barrier potential. The simplest book for this is your B. Kumar and S.B. Jain. So this book by Electronic Devices Circuits by B. Kumar and S.B. Jain, this is the simplest book which covers all these topics in brief, and whatever is given in this book, it is sufficient for your preparation of for your exam point of view. Now coming to next topic, which is your diodes, which is the carry forward of the PN junction. So here if you will see, you should have some idea of what are your ideal and practical diodes. So their VI characteristics, what is the difference between the two, and then diffusion and transition capacitance. This you should know the equation, as well as small numerical can turn up on these two types of capacitances. Then different clipper, clamper and rectifier, either it is half wave or it is bridge rectifier. You should be prepared for small numericals on these topics, plus derivation of your RMS value, DC value, your rectification efficiency, ripple factor, all these things you should be clear about. Now coming to your diode series and parallel diode circuits. In series and parallel diode circuits, small numericals you can take, and these numericals are given in this Boylsted book in very good detail. There are all types of numericals which are covered. You can take your solved numerical, as well as you can go through the back numericals which are unsolved numericals, which will give you a good idea of how to put the diodes in series and in parallel and how to solve the circuits requirement. Then coming to Zener and avalanche breakdown. Zener and avalanche breakdown, these are the two breakdowns. So this you should know as theory, when your Zener breakdown occurs and when your avalanche breakdown occurs, and what is the phenomenon behind them. Then finally coming to Zener diode and Zener diode as a voltage regulator. So be prepared for small numericals on this voltage regulator portion for your exam point of view. Specifically, you have to do the calculations related to your minimum maximum value of load resistance, calculation for your series resistance, when your diode is in breakdown, or when it is going to work as a voltage, when it is going to be work in breakdown region as your voltage regulator, or when it is coming out of the region. So these small numericals, they are also given in this book, so you can refer to this book for this particular portion. Now there are some special diodes like LED, Schottky diode, photodiode, optocoupler and solar cell. These topics you have to prepare only for short notes. No numerical will be turning up on these topics. Whatever numericals are there, they will be basically related to this portion of your diodes only. This portion you have to prepare as a theoretical point of view. What is your different diodes? Suppose your Schottky diode is asked in your exam. In that case, you should be knowing what is its IV characteristic, how it operates, how its IV characteristic different from different other types of diodes, and what are its applications. Similarly, for rest of the diodes, you have to prepare the similar theoretical concept, and it can appear as short note in your exam. So this was related to your second unit. Then coming to a third unit, which is your bipolar junction transistor. This topic is very important for your exam point of view and also for the understanding of your electronic concept. So something I will cover after covering your syllabus. At that point, I will tell you what is the importance of which topic, and if you want to go for your company interviews or you want to go in electronics stream later on as a research you want to consider. So which topics you have to take and which will be for most important for you, this I will be covering later on after completing this syllabus overview. So now coming back, the complete syllabus I have divided in two parts. First part says your device structure and physical operation of BJT. So basically how the device is formed and how it physically operates. This is a theoretical portion which you should know for the better understanding of your rest of the device parameters and its characteristics. Then obviously voltage, current voltage characteristics you should be knowing. BJT circuits at DC and the Iber-Small model and VI characteristics in common emitter, common base and common collector. All the three configurations you have to do. Basically A part you should take from Boylsted. That's why I have written A and B you can take from Boylsted, but B part is given in more detail in your Cedro and Smith book. So for very first part you can refer your Boylsted book, in which your BJT circuits at DC, VI characteristics and your current voltage characteristics, everything is given in very much detail. But for Iber-Small model you will not find it in Boylsted, so you have to consider Cedro and Smith book. Now after this comes your determination of operating point, introduction to small signal parameters, gain in common emitter, emitter follower, simple current mirror, BJT as a switch. So these topics are better given in your Cedro Smith book. So for understanding of these topics, you should better go to Sedra-Smith books. There are some points, please listen carefully. These are some points which I have specifically mentioned in this slide, which you have to cover in this topic as well as the next topic, which will be your Mosfet. Mosfet I will be covering in next slide because it is your unit 4. But this things will remain same, either it is BJT or it is Mosfet, both being the transistor. So what you have to do in both the Mosfet and BJT, you should be knowing what is the DC model. DC model means large signal model. How, if a large signal is applied across your device, how the characteristics will appear. So in BJT case, it is Iber-Small model, which explains your DC model. And then comes your AC model. AC model, you can, there are two forms, in T model form or your pi model form. So you should be having clear idea when to use DC model and when to use AC model. This is very, very important because whenever you are going for biasing, at that time your DC model will be used. And this DC analysis you will be doing by using DC model, and it is used basically for calculation of your quiescent point or your Q point or your operating point, whatever you call it. So whenever you are going for DC model or DC analysis, you will calculate your Q point or operating point. But once you apply your signal, which is small in amplitude, whenever you apply small signal, what you have to do is your AC model will come into picture and your AC analysis will be carried out. So in this you will calculate the small signal parameters. Small signal parameters means your input resistance R in, your output resistance R out, your current gain, your voltage gain. So all these parameters will be calculated through AC analysis, not by DC analysis. So whenever you will use your device as an amplifier, so there will be two parts of that amplifier: DC analysis for calculation of your Q point, and then AC analysis for calculation of your R in, R out, AI and AV. So this portion you have to cover basically for your common emitter amplifier. So common emitter amplifier, you should expect that small numericals can come, and you have to carry out DC as well as AC analysis. And DC analysis can be asked in exam for any of these configuration: common emitter, common base, common collector. But AC analysis, because specifically common emitter amplifier has been mentioned, so it will be asked for your common amplifier configuration only. And emitter follower, you should study the circuit of emitter follower. Emitter follower is nothing but your common collector configuration. You should know the basic characteristics of your emitter follower, what all the advantages and where this circuit is being used. Then simple current mirror, again in simple current mirror, either small numericals can be asked or directly the question can be theory based, requesting you, demanding you to draw the circuit and explain how it is acting as a current mirror. So, and last topic is your BJT as a switch. So BJT, I think you must be covering in the class. It can be used as a switch as well as an amplifier. So BJT as a switch, how it is used, so that portion also you should know. And this is also again theory type portion. No numerical is expected from this portion, only theory will be asked. So you should be knowing how BJT acts as a switch. You should be in a condition to explain that portion. So books I have already discussed. For A part you can, for A and B both you can refer for Boylston, and B part specifically you should refer Sedra-Smith also. And again numericals for B part you should take from Sedra-Smith as well. Don't only concentrate only on your Boylston. You will find Boylston to be a simpler version of your Sedra-Smith, but Sedra-Smiths will clarify your concepts in more detail. Now coming to next unit, which is your unit 4, Mosfet circuits. So here again focus area is same as BJT. One thing I forgot here, your fixed bias, emitter bias and voltage divider bias. These three biasing schemes you have to study in BJT. It is not specifically mentioned in the syllabus, but be careful that any of these bias configurations can be requested in your exam and questions can turn up on any of these three configurations. And specifically I have written here that you have to focus on DC and AC analysis, but because for sure your DC analysis or AC analysis questions will come in your mid as well as in your final exam. And this is the most important portion of your transistor, either it is BJT or it is Mosfet. So DC and AC analysis, I have already explained you what your DC analysis and what your AC analysis, what information they give you after this analysis. So focus area will remain same. Again here what you have to do, characteristic and working principle of JFET. JFET you have to study only a little bit. JFET being a device which is now not that much used in the market, so but its theory will help you in understanding you the Mosfet. So you should just understand the working principle of JFET, nothing more than that. You need not to go in deep of JFET topic. Then device structure and physical operation of Mosfet. This Mosfet is very, very important for you, your exam point of view as well as for your industry point of view, because all the integrated circuits, maximum integrated circuits nowadays are being built using Mosfet devices. So companies are also very much interested in whether your Mosfet concepts are clear or not and how much idea you have. So I will request you that you should study this topic very sincerely and try to understand the concept. So it's device structure and physical operation, then enhancement mode and depletion type mode. These are two types of modes of Mosfets. So both modes should be clear. Basically at the time of fabrication itself, it is decided either it will act as depletion type Mosfet or it will act as enhancement type Mosfet. So this please be clear what is enhancement mode and depletion mode. Then current voltage characteristic of your Mosfet, biasing schemes for Mosfet. Again same biasing schemes which you have discussed in your BJT, same biasing schemes you will covering here, and the three configurations, common drain, common source and your it has been incorrectly mentioned, it is common drain, common source and common gate. So these three configurations, common drain, common source, common gate, just like your common emitter, common collector, common base in your BJT, these three configurations IV characteristic should be clear, input as well as output. So in exam your input output characteristic of any of these three combinations including your BJT three combinations can be asked. So you should be in a condition to plot them and explain them. Then comes your low frequency transistor model. This is again your small signal model or your EC model that we have discussed in case of BJT. Similar model you have here also, and for using that model you have to perform the small signal analysis of common source amplifier. Common source amplifier is just like your common emitter amplifier. So common source and common emitter amplifier you can expect small numericals. Basic numericals, and these numericals definitely you can refer these two books. The numericals given in these two books, similar numerical will come in your exam also. And then your source follower, this is just like your emitter follower. So just similar way like you have covered in your BJT, your emitter follower, the theory related to its circuit, its operation, its application and what are its advantages of using that circuit, that you should be knowing. Then your estimation of voltage gain, input resistance, output resistance, all these are again related to your small signal analysis, just like you have done in BJT. Similar ways AC analysis or your small signal analysis will provide you voltage gain, current gain, input resistance, output resistance calculations you can carry out. Then simple current mirror, Mosfet as a switch. Just like your BJT, your Mosfet can also be used in current mirror configuration, and similarly it can be used as a switch. So all the topics here, they match approximately to your BJT, both being transistors, both have their own advantages and disadvantages. So you should be knowing all these topics in similar fashion. Now this is your last unit, which is operational amplifier. For operational amplifier you can refer to Cedar-Smith book, as well as there is one more book. Those students who are finding Cedar-Smith to be little bit tough, only for those students I will advise to go for this book. Linear Integrated Circuits by D. Roy Chaudhary and S.B. Jain. Otherwise, your first book, this is more standard book and you will not find any mistake there. Small mistakes I have seen in this particular book. But if you are finding it tough to go through this book, Cedra-Smith, then you can use this book for your basic understanding of your operational amplifier. In operational amplifier, basically you should be clear about the ideal operational amplifier, what is ideal and how is your practical operational amplifier, it differs from your ideal operational amplifier. Then what is the voltage transfer characteristic, how it operates when it is in linear mode as well as in saturation mode. You should be clear about that. Then what is the concept of virtual ground? Please be careful when you are studying this virtual ground concept. It is applicable only when negative feedback is used. Maximum of the students, they use virtual ground concept irrespective of your operational amplifier, how it is connected in the circuit, whether negative feedback is there or not. Without caring of that, they just go for virtual ground. So anyways, you have to be careful. This you will be studying as your last unit, so you might not have studied by this time. But still you have to remember that you have to be very clear about virtual ground concept, which is very important. Then these are few non-ideal parameters: offset voltage, CMRR, slew rate. You never get your ideal required values. So what are the reasons and how to improve them? This small topic you have to see: slew rate, CMRR, common mode rejection ratio and offset voltage. Now turns up op-amp. Till this point everything was theory. This was all complete theory of your operational amplifier, explaining its basic characteristics, ideal and practical operational amplifier, then what are the non-ideal factors and how they will be, how they turns up in your practical device, and what are the desired values of that. Now coming op-amp in open loop configuration, comparator, zero crossing detector, inverting and non-inverting amplifier, summing and difference amplifier, unity gain buffer, integrator, differentiator and log amplifier. These are all the applications of your operational amplifier, op-amp applications. So all these applications, circuit you should be knowing. That means it can directly be asked that draw the log amplifier and explain how it is behaving as log amplifier. Or in numerical can be asked, that is the values are given for different parameters and you have to determine the output waveform or output voltage that you will be observing. So for these topics which I have shown here, you should be prepared for theory as well as numerical. Theory means whatever circuit is asked, suppose inverting amplifier is asked. So you should be in a condition to draw the circuit, and if circuit is given and parameters are given to you, then you should be in a condition to calculate the gain or waveform, whatever is expected from the particular circuit. And I have already shared with you that this is the most standard book which you can refer for operational amplifier, or otherwise this book, it is a simplified version of your operational amplifier based circuits. You can also go through this book for a basic understanding of operational amplifier. These were the all topics that you will be covering in your EDC. I have tried my best to explain in short which topic you have to take from which book and how much depth you have to cover. There is a small suggestion from my side. Being the teacher of this subject EDC, I will request you, as you are coming from electronics and IC background, my request is take this subject seriously, because this subject is the one in which students have maximum supplies. That was also one of the reason why I am taking this lecture here and getting it recorded, so that you can listen to it, so that you can prepare well for your exam. And secondly, it is not only the whole purpose that you want to get good marks, so you have to take it seriously. This subject is really important if you want to prepare or you want to have your career in the electronics line. I think you must be knowing nowadays your VLSI industry is booming up. There are a lot of jobs which you can easily grasp in VLSI industry, but if you want to go in that area, this is the main subject which will help you in developing the basic concepts. If you have not understood the concept of BJT, you have not understood the concept of Mosfet, you have not understood the concept of basic amplifier, here we have taken operational amplifier, then it will be very tough for you to clear any interview round basic round of any of the electronics based company. And moreover, whatever subjects you will be studying in from third semester onwards, if they are related to electronics, these are the basic of all those subjects. If you are not knowing BJT, not knowing Mosfet, you are not having any idea how they are operating, then you will not be able to understand any of your higher subjects. So this is my humble request that all of you please take this subject seriously, try to clear your concepts so that in future you don't face any issues till your final year in clearing your electronics based subjects. Otherwise, it is going to be a big task in front of you. I am telling you, it is going to be really a pain for you. Many students come to me when I am taking this subject in higher semester, like you will be studying electronics circuits, then you will be studying AIC, then the other subjects are also there. They come to me, approach me, ma'am, our concepts of basic BJT and Mosfet are not clear. So we are not able to understand whatever you are teaching in the class. So please tell us how to manage with it. So I just advise them, it is not possible for me to take a complete semester, repeat the complete semester, take all the classes again. So I advise them, go to your notes or refer to your notes and open your books for your this subject, your EDC subject, and then clear those concepts and then come back for the class. Otherwise, it will not be possible. So if you will take this subject seriously in your this very first semester, you are in second semester currently. So if you will study it carefully, it will be a easy path for you studying this subject or related subjects in the electronics stream or your IC stream. Otherwise, it will be going to be very tough. Thank you. I hope that everything I was trying to explain you, I was in a position to clear you. Thank you very much. Thank you.